Welcome everybody, and welcome to this crash course on chaos engineering. We're gonna have 3 speakers today with us. So we're gonna start with Patrick from Gremlin that is gonna give an overview on chaos engineering, and then we're gonna have Andreas and Rafael from Container Solutions that again they're gonna discuss chaos engineering and then break some things as well during a couple of demos. So it should be fun. I think that's all for now. I will leave the stage to Patrick. Thank you for joining us today, and yeah, the stage is yours.
So thank you, Carla, for the quick introduction. Good morning, people. As already mentioned, my name is Patrick van der Bleek. I am a solutions architect at Gremlin, where I help out our customers across Europe, Middle East, and Africa build out their chaos engineering practices. Gremlin itself is a hosted SaaS platform that allows you to run chaos engineering experience in a really safe, simple, and secure way. And I joined Gremlin earlier this year to start their European organization together with my colleague Roald. And before that, I had a similar role at Docker for 3 years. And before that, I spent 6 years at Red Hat. So I've got a bit of a background in Linux, open source, and a lot of stuff related to things like containers and things. Today, I'm going to be discussing the origins of chaos engineering, what it is, how to start, and how to mature your chaos engineering practice. And we're going to do this by answering the 5 W questions: what, why, when, where, and who. So let's start off with the first one, and maybe just a quick yes in the chat box. How many of you know what chaos engineering actually is? And the question that also automatically follows up on that is, how many of you know what Chaos Monkey is? And that is always an interesting one, because people say we know chaos engineering, people say we know Chaos Monkey, and the third question is, of course, how many of you know what chaos engineering is because of Chaos Monkey? And there's a reason for me asking that question, because if you look at Chaos Monkey, that is not chaos engineering per se. It's one of the base foundations of what chaos engineering is nowadays, but it's a bit more subtle than just toying around with EC2 instances and shutting them down in random fashion. But before we dive into that, let's look at the word chaos and try to find that in a dictionary. You're going to find 2 different meanings, and the first one you're probably going to find is complete disorder and confusion. And although I recognize this from my home, because I've got 2 small kids, I would not advise causing any disorder and confusion into your IT infrastructure. And that's why sometimes it's better to define something by actually defining what it is not. So as I said, it is not Chaos Monkey. The ultimate goal for Chaos Monkey was just and a good end goal, but the approach had a couple of pitfalls. One of them, they started randomly terminating hosts instead of targeting really particular instances in their infrastructure. So they didn't have a lot of control over what we call the blast radius. They started with an entire environment instead of starting with a few hosts, and then started growing that blast radius. The other one, they forced to run the tools on all the teams within Netflix, often with little to no communication towards those teams. The one thing that the tool actually did really well, or what the teams at Netflix did really well, they ran that tool automatically and continuously to ensure there was no backwards drift. So if they fixed some software error in their code to be able to cope with EC2 instances failing, they wanted to be sure that their application was still capable of failing in a graceful way, version after version. So they were running this automatically in production to validate that they didn't have any regressions, that their application was still capable of failing in a graceful way. And if you're going to remember nothing else from this presentation, do me a favor, remember these 4 bolded words you're going to see here. The first 2, thoughtful and planned. The term chaos may be misleading. It's much more about trying to validate and disprove a hypothesis. The other 2, revealing a weakness. The ultimate goal of chaos engineering is to shine a light on latent issues that already exist in your environment. Remember, if you're going to go up an attic and you're going to shine a flashlight and you see a bunch of spiders and you turn off the flashlight, Those spiders are not going to disappear. They're still going to be there, right? So let's go back to that dictionary I just mentioned. The other meaning of the word chaos that we see a lot is the one that is used in the physics community. And there you'll find the following meaning, and I'm going to quote: the property of a complex system whose behavior is so unpredictable as to appear random, owing to great sensitivity to small changes in conditions. And that's exactly what we're doing when we're practicing chaos engineering. We're finding the small changes in conditions that have a huge impact on the predictability and the reliability of our applications. Yes, we're going to introduce chaos, but that doesn't mean that we do it chaotically. And as with any experiment, you want to start with the smallest increment that will yield a signal. You want to over-communicate, especially if you're an SRE team advocating the practice for other teams. And this really is a practice that needs to be iterated on and continuously improved and automated, etc. Just like you're doing with DevOps, with closing the feedback loop, chaos engineering is basically going through that same loop. You learn from your experiments, you fix them, and you keep on validating them. So where did this practice actually come from? And by no means it's a new practice. It actually started back in the Stone Age. Whenever you find something new on the ground, you pick it up, stick it in your mouth, and see if it kills you. That were the really basic principles of chaos engineering. But all joking aside, if you go back to prior to 2010, there was a guy at Amazon called Jesse Robbins, and his official job title, don't trust me for this, he was the master of disaster. It was official job title on his business card. And that he was because he was responsible for entire website availability within Amazon. And because he had a lot of experience being a fireman, he started a project internally called Game Day, which meant to increase reliability by purposefully creating failures in the Amazon website. Fast forward to 2010, roughly, many large enterprises start practicing proactive disaster recovery testing behind closed doors. And the Netflix engineering tools actually created the Chaos Monkey back in 2010 to facilitate Netflix moving from a physical infrastructure towards a cloud infrastructure. They realized we're going to get less control over our physical infrastructure, so we need ways to test our application to be resilient to infrastructure failure. A year later, they announced a Simian Army, which basically added additional failure modes to what Chaos Monkey brought, allowing them for more testing of more complete suite of failures. 2014, Bruce Wong coins the term chaos engineer while he was working at Netflix, and the industry starts to join them in practicing chaos engineering as a means of increasing resilience in complex systems. And finally, 2016, the year that Gremlin was founded by Colton Andreas and Matthew Fornchari, actually were pioneering chaos engineering back at Amazon and Netflix, where they came from. The entire company Gremlin is basically built by pioneers in this industry from organizations at internet scale. So coming to why you should practice chaos engineering. Well, because failures are inherent to complex systems and will cause downtime unless tested for. Complexity is only on the rise. As things get more complex, there are more and more ways to fail, and failure means losing money. I'm not saying that you can root out all of the failure modes, but you can start to eliminate whole classes, reducing downtime right from day one. And there's a lot of low-hanging fruit you can start with. Let's look at disk exhaustion, timeout tuning, all those kind of things. And according to Gartner, the only way to successfully operate distributed systems nowadays is with chaos engineering. Gartner actually draws a direct connection between applying chaos engineering and uptime. Leading companies like Amazon, Google, and Netflix apply that as part of their normal delivery routine, and many more will follow this practice over time. And this is actually one of the favorite slides we have because it tells a really great story. It's traditional testing is dead and DevOps is what killed it. So one of the remarks that one of my colleagues always makes. And I'm kind of liking this because it tells you exactly why chaos engineering is so important. Because we're talking about dependencies on networks we no longer own. Infrastructure that is outside of our control. Orchestrators that are complete black boxes to us. Open source or legacy dependencies that have unknowns. And last but not least, the people that can be unreliable. So if you look at, for example, back in 2017, Amazon lost an entire region for S3. That was caused by a single human error. So organizations need new ways of testing other parts of the application stack to make sure that everything is configured accurately and that all processes for incident management and operations are in place and functioning as they are expected to be. So there's a big shift going on in architecture, going from monolithic applications towards microservices. Everybody's aware of that. And this means larger, more distributed systems, which equals to more complexity. These systems you see here are built upon hundreds or not thousands of microservices. These death balls, as I like to call them, are a trace of the Amazon and Netflix microservices architecture of about 5 years ago. Imagine what that would look like today. Finding a failing component in architectures like these is like finding a needle in a haystack. There's also a shift in hosting from on-premise servers towards the cloud. Which means that engineers have less control over the infrastructure and they're no longer managing their own hardware. So they need to begin architecting their applications for failure. So they need new approaches to testing those failures in those large balls of death of interconnectivity. But maybe you are Netflix or Amazon, or you don't have that complexity. Well, not yet, as we say. Another really crucial part of resilience is people. The time it takes to detect and resolve an outage, typically measured by your MTTD and your MTTR, is not only determined by your system's reliability, but also by your people's ability to respond to incidents as they happen. Fire drills is a mechanism in chaos engineering that helps you train your teams to respond to incidents and verify if your runbooks for incident management are still up to date. Because let's be honest, 4 a.m. is not the time to find out that your colleague changed the startup sequence for a specific application and forgot to update documentation. So typically, cost of downtime is seen as the loss in revenue and employee productivity during an outage. However, there's a lot of cost that occurs after the outage as well, some of which we as engineers might not even be aware of. So does your employer have SLA agreements in place with customers? That might mean that they have to provide them with cashbacks for the outage as well. And what about the immeasurable ones like brand defamation, losing money, customers because your services are interrupted so often, or employee attrition because they get burned out by being paged during the night week after week. And at some point in time, they will start looking out for other jobs which provide them with a lot less stress. On average, 1 hour of downtime will result in about $300,000 in losses. And these numbers get even bigger with companies that operate at internet scale. It's estimated, for example, that Amazon loses $13 million per hour of downtime. So when would you start applying chaos engineering? Well, unless you are still using a typewriter to run your business, I'm assuming that your company is running some digital transformation program to become more agile and be able to adjust to the ever-changing market faster. This will mean that your systems are going to become more complex, which means that finding the cause of a failure is going to become more difficult, especially at times when there's not enough caffeine in your body and your mind is running at its full capacity as early as possible. And we have heard basically every excuse there is in the book about why a company would not be ready for chaos engineering. First of all, we don't have time. Well, respectfully, what is more important than making sure your business is up and available? The odds are that day-to-day operations are already being filled with reactive firefighting as you speak. My favorite, things will break on their own. Sure, at 3 a.m. in the morning, waking up engineers who have to then dig through logs, finding out what the peep is going on with your systems. I would rather break things on my own time. Let's say 3 p.m. in the afternoon, coffee in my body, and the entire team engaged and focused. And the final one, we don't know how to start. We'll start simple. Are you resilient to CPU pressure? Is your application resilient to memory pressure? Start building from there. What are some assumptions about how the systems work? Start validating those. And part of the issue behind this mentality is the definition of operational maturity. Majority of the industries considers being operational mature as being ready to fight incidents. However, if you really are operationally mature, you're being proactive in testing, making sure that you are ahead of those incidents. And there's a relatively easy way to determine if a company is ready to start chaos engineering. Well, first of all, on the left side, you'll see the programmatic requirements. If any of these questions are answered with no, start fixing those first. On the right side, technical requirements. Without some basic observability, you're going to be flying blind, and that's really dangerous. But if you can answer all of these questions with yes, congratulations, it is time to unleash chaos in your organization. And there's a level of maturity with chaos engineering for every step of the journey. Let's start with some infrastructure failures. First of all, local failures. Start small by testing to make sure you can handle your own failures. Yeah, you can't start too big, but start by putting out the fires in your own house. Things like CPU, disk, or memory consumption. How do your application handles when things are shut down or processes are being killed? What if clock skew occurs? Second step, look at external failures. Once we have our own stuff under control, can we also handle other people's failures? So are we relying on external APIs from other vendors or other partners that might break down? Are we capable of handling those failures? Let's try and see if we can use some network attacks, for example, to just black hole traffic that goes into a specific vendor, or let's play around with DNS, introduce latency into our application landscape, or maybe even a bit of packet loss. Next, move up the step and start testing at the application level. And when you're done that, finally, let's automate chaos to prevent drifting into failure and regression of past issues. And let's make sure chaos engineering is becoming a mandatory part of your application delivery. Let's say, if my application is ready to go towards production, it first needs to pass a set of given chaos engineering experiments before it is allowed to be promoted. Next, W is where to chaos engineer. Well, as you're going to go through all of the maturity levels of chaos engineering, the ultimate goal is going to be testing in production. However, unless you are really sure that your job doesn't depend on it, I would hold off for that for now. It should be on your horizon nevertheless as your ultimate goal. And no two environments are exactly the same. I haven't seen a company yet that has production and all staging environments configured completely identical. And that's pretty logical, right? It's an expensive practice to copy all of those environments exactly. And as James Hamilton states here, unless you're testing in production, there's no guarantee your recovery safeguards will function. But testing in production sounds scary to a lot of people because that is where our customers are living. So we always recommend starting small and carefully and purposefully increasing the blast radius. And this can mean experimenting with a single or a few hosts at first, not the entire fleet, but it can also mean starting in development and slowly expanding outwards. And in addition to a carefully defined blast radius, chaos experiments start with a small experiment magnitude and progressively scale up. So, for example, inject a small amount of CPU latency or memory loss, and start increasing that as you build more confidence in how your systems are responding. And this is the cycle of expanding that blast radius, which starts over as you escalate up those environments. First of all, you start adopting the practice in development phase, so your engineers are architecting your application for failures. Once you're confident with a particular failure, begin testing and staging on a subset of hosts and start expanding. And finally, rinse and repeat in production. So you're absolutely certain that even in a production environment, you are capable of handling that failure in the best possible way. Who should chaos engineer? Well, put simply, the internet is unreliable. If you blindly trust it to always work, eventually it will disappoint you. So any company that relies on the internet to operate at their business is going to be a perfect candidate to start chaos engineering. And it's easy to see the ramifications of how brittle this rapid new innovation digital world can be. Social media brings headline news of big failures to the forefront nearly every day. Whether it's regular e-commerce failures on Black Friday, breakdowns at banks or financial institutions, and in worst cases, life-threatening incidents on airlines. The cost of major technological breakdowns goes far beyond just the billions lost in company revenues. And some of these pieces of the infrastructure aren't completely in control, but customers don't care. It is your site that is down. They don't care why. They don't just know that they're unsatisfied with the experience with your company. So what successful, innovative companies have realized is that to move towards optimal reliability and to give control back to your engineers, to create a culture of proactively testing for failure is the answer. Companies who rely on the customer-facing web applications to generate revenue and customer satisfaction, they're doing that not to inject chaos into their environment, but to actually remove the likelihood of chaos in their environment. Injecting failure into our systems lets us see how they will react, what side effects they will have in a large disaster, and so they can prevent them from ever recurring. So their best day, a launch of the new product, or Black Friday, or a new streaming series, will actually be their best day, not their worst day. The result: higher customer satisfaction, higher employee satisfaction, and an increased innovation focus instead of fighting fires in the organization. So no matter what the business, all rely upon the customer and that the customer have good experience. You may recognize some of the above names, but each of these have found value in proactively testing for failure. But how exactly are these companies leveraging chaos engineering? Well, let's look at a few use cases and the type of experiments you can actually use. And I know that Andreas will go a bit more detail into these kind of attacks later on after this session. So please pay attention to that one, because that's probably going to be the more interesting stuff. But first of all, validating your monitoring. Monitoring is of crucial importance, not only for your observability purposes in chaos engineering, but also running it in production. When do you want to know that you have an issue in your systems? When your customers start calling you, or when they start posting complaints on social media on how awful your website is? Chaos engineering is used by a lot of companies to verify that their monitoring picks up on the issues before their customers notice it. And this is where we start bringing down two key metrics of our mean time to detect and the mean time to resolve, the MTTD and MTTR I was talking about. Incident response plans. How often do you test your incident response plans? Are you 100% sure that the guy that is on call at night has all of the tools and processes available to quickly get your applications up and running? These experiments you see here lend themselves perfectly for running fire drills to see how your staff responds and handles incidents. And with more distributed systems and external dependencies, we need to ensure that our systems will fail gracefully. Losing a non-critical service like a review service should not bring down the entire website. Similarly, losing connection with your DNS provider should fail over to another provider. Using chaos engineering, you can ensure that these controls are in place and the impact of dependency loss is minimized. Finally, Kubernetes failures is one of the most popular use cases for chaos engineering as well. You can start ensuring that resource limits are correct, that you can handle network and DNS latency and losses, and you can ensure that non-critical servers don't knock out your entire application. And just as a simple example, Backcountry is one of our customers. He's a big e-commerce provider in the US. They had a 72-hour SLO breach on Black Friday 2017. The issue they were issues writing to the database, and that caused the shipping warehouse robots to misship orders during that time. After Black Friday, their entire engineering team had a fix really quickly, but they couldn't verify, because in their staging environment, where they should be able to verify that issue, they didn't have any picker robots, so they can't really test if it worked okay. So what they did with the help of Gremlin, they installed the Gremlin product in their production environment, ran a game day with the entire team, verifying that fix and identifying some other latent bugs as well as part of that process. End result, the pickers didn't miss up any orders despite the introduced database latency that day. And more important, the 2018 Black Friday went off without any form of incident whatsoever. So let's quickly review. What is chaos engineering? Experimenting in a scientific way with your applications. Introducing small controlled issues in your environment to reveal weaknesses that you are unaware of or validate your hypothesis. Why should we practice chaos engineering? Well, that's relatively easy, because it's never a question if something fails, it's a question of when something will start failing. So failures are inherent. When to apply chaos engineering, we'll start tomorrow. Find an environment that allows for experimentation. Take a case that you're familiar with, maybe the root cause of an outage you've had earlier. Once you're more comfortable, then start trying to uncover the world of the unknowns. And ultimately, where to chaos engineer? Ultimately, you might want to be Netflix. We are so confident our applications can handle failure of EC2 instances, we test it in production. But as I said, start in an environment where you know that the impact is going to be limited and you have confidence that you're not going to impact your customers, and start growing from over there. Who should play chaos engineering? Well, everyone. There are no excuses not to practice chaos engineering, remember? And how to chaos engineer? Well, of course, we like to think that the Gremlin platform is the ideal tool to use that, but there's a bunch of tools available out there, open source, commercial offerings. Start playing around with those. If you want to know more, we have a Slack community of over 5,000 chaos engineering practitioners learning from each other day over day. So come in, say hello. You're welcome, really always welcome. Plus, we have a forever free version of the Gremlin platform you can use as well. And that will allow you to start with your first couple of experiments like CPU shutdown or network black hole attacks. That being said, I want to thank you for joining. Thanks for your time. And I want to hand it over to the Container Solutions team.
Great. Thanks,
Patrick. That was a very, very insightful presentation. Let me give you a virtual clap.
Thank you.
Good. More people clapping. You can ask very quickly a question now, or we can leave the stage to Andreas, and yes, yeah, I can see the more clapping there. And we collect questions at the end.
Good.
Cool. Okay, over to you, Andreas.
Great. Hello, everybody. One moment so that I can share my screen. All right. Here we are. Sure. You should see my screen.
Yes, we see it. Yeah.
Great. All right. Thanks, Patrick, for the great presentation. I think we covered very, very well the important aspects of chaos engineering. The 5 Ws are really important to understand. Chaos engineering has been a very interesting technology that has rapidly evolved the last few years, especially with open source, but also with commercial platforms. And we at Container Solutions, we are cloud native consultancy. We work with a lot of different clients with a lot of different things. And me and Rafael, at the moment, we are working with a client implementing a chaos engineering platform. And we want to share our experience with you guys. But more importantly, we want to break things. That's what we like to do. So we have prepared a couple of demos for you guys to see. Very briefly, who we are. I'm Andreas Krivas. I'm a lead engineer in Container Solutions. Been there for almost 2 years now. Time flies by. Engineer in the background, mainly in operations side of things. So I was very interested to see how chaos engineering can be applied on that side of things. Yeah, that's in a nutshell, quickly my background. Rafael, maybe you want to introduce yourself as well?
Sure. So I'm Rafael. So and yeah, looking at this picture, it makes me think I need a haircut. Yeah. But yeah. So yeah, I've been working Container Solutions like for clients on different projects, mostly infrastructure. But I have like a development background, so it's been a shift for me in the previous years. So yeah, pretty excited about it. And these days I'm working on a project with like chaos engineering too. So that's why we'd like to share our experiences and what we're learning in these projects with you guys. Yeah.
Great. Feel free to ask questions if you guys, if there are questions that pop up in your mind while we present. Let's start with some basics. We're gonna go a bit more in depth into what is a chaos experiment, what are the principles, the basic scientific principles behind it. Then we're gonna go more into depth into different kinds of experiments that you can execute. Patrick already has mentioned a few of those, right? So we're gonna try to visualize it a bit better or more in depth. And then we're gonna go again one layer below on who should execute experiments. Everyone is the short answer. We're gonna really try to understand how different types of roles in an organization can actually leverage this type of testing. And then we're gonna share with you some of our key, let's say, key points that we identified in the last few months when it comes to different chaos tools that are out there. We're not gonna go very much into depth on that. Happy to answer any questions, but there are a couple of nice takeaways that I think it's worth sharing with everyone. And then we're gonna dive into the very fun stuff. We're gonna deploy 2 demos for you guys. One will be to increase the CPU of an application and see what happens to the whole platform. And then is introduce network latency between 2 applications, and then see if that will break our platform. So first things first, what is a chaos experiment, or what are the principles behind a chaos experiment? The community has tried to standardize let's say the life cycle of an experiment. Where do you start? When does it end? What do you do? So I'm going to briefly go into each one of these 5 stages. And in our experience, it's very, very important that they are respected or they are followed for every experiment. First, when you have an application or a system that you want to create chaos, or you want to test and verify some of your parameters or anything that you like to check, first you need to define your steady state. The steady state is defined as the idle situation of an application, or how it behaves under normal traffic, or under normal workload or utilization. How does the application perform when nothing is wrong or when there are no special circumstances? This is your reference. This serves as how is my application at the moment? How does it look like? Then, once you have this clear and you know how the application or the system behaves under normal circumstances, then you need to make a hypothesis. Also, Patrick touched upon that, right? You need to hypothesize, okay, if I increase the CPU, or if the CPU is increased in the application, I expect this to happen. I expect the application will crash, or I expect that the whole system will crash, for example. You need to make a hypothesis about how your system will behave if you introduce a certain disturbance, a certain chaos. Once you have the hypothesis, then you go to design the experiment. Designing the experiment, you could use any tool that satisfies your requirements, but it's important to design it in a very controlled manner. Patrick also mentioned the blaster radius, right? It's very important to say, okay, I need to ensure that I increase the CPU, for example, only in this application and not in the whole system, because then the chaos could spread and suddenly you have a bigger problem that you wanted to create. So designing an experiment is very, very critical, very important, and needs to be very thoroughly thought and implemented. Then you execute the experiment. You execute the experiment either during game days, which is popular, let's say, experiment days, or during fire drills, or when you actually think it's an appropriate time. But then key is that you have proper monitoring and observability behind that. And the reason is, and we've seen that also in our client at the moment, you execute an experiment, the experiment successfully increases the CPU, and everyone says, hey, experiment successful. But that's the misconception. The chaos experiment, was successfully executed, but that doesn't mean that your application behaved as you expected. You actually have managed to shift your focus to the chaos experiment and not to the application. And that is a very important trap that we need to avoid. So it is key that you have observability for your application or the system under stress, under chaos, and you keep your focus on that. You try to see how the application behaves or how the system behaves, and not how the chaos experiment goes, right? Of course, you need to have proper monitoring to see the state of the experiment and if it's completed or if there's an error, but the focus should always be on the application or the system under test. Once you gather the results after the experiment is finished, probably you're going to have a report, or you're going to see your dashboards, and you're going to identify a few issues. This is when sometimes people stop. They say, okay, I identified this issue, I need to work on it. But this is not where we should stop with experiment. You need to immediately try to remediate or create a plan for remediation to fix the identified issues and test again. Make a new hypothesis. Okay, after this fixes, now I expect this to happen, right? And iterate until you're satisfied. It is important not to break the loop and always have a feedback way in order to get all the lessons learned from the experiments back to the hypothesis. And this is how you slowly, but in a controlled manner, identify hidden issues or anomalies in your applications with chaos. Now, this is the 5 steps, right? Or the 5 principles of chaos. Now I'm going to give the baton to Rafael, where he will explain the different types of, some of the different types of experiments we can run.
Sure. So here we have like a diagram of a hypothetical setup that we might have in our companies, right? So that's not too far from what we find in lots of clients. So there are like different data centers or different regions, and there is like a Kubernetes cluster. So in this example, we have one control plane node and 2 nodes running applications, right? So, and with an ingress load balance to the cloud where you're running like AWS or GE or Google Cloud, right? So with this architecture, that's where we start thinking what would be a good target for chaos experiments, right? And just, I think Patrick and Andreas already mentioned that it would be nice to start small when something controlled, right? But this is just to show what we could see happening in a real life scenario, and then think about reproducing that in a controlled manner to make sure the applications could handle, right? So the basic experiments could be like involved 2 application boxes that we can see, right? So maybe just removing one pod, one container of that application, maybe just introducing latency between application A and B, right? And then once we get more confident with that, doing more increasing the blast radius of the experiment, right? Like maybe removing one Kubernetes node and see what happens, right? And I've been in a situation where we even try to run a drill, bringing down one data center, one region to make sure everything would be migrated, all the traffic from external connections would come to another data center. So these are very different layers and very different experiments that we can run. But it's all about you figuring out, looking at your environment, at your applications, right, and see what could fail in a real world scenario, and then start planning experiments, so check if they actually would work fine in the case of a real situation. Cool. So this one, I think Patrick mentioned that, so everybody should run, right? So chaos experiments, no matter what is your role in your company. So, but that's something that we found, that we usually find in our clients. So we are engineers, we like to write code and just push things to production and let people using our tools. But we very soon we face this problem with people, right? Which is not supposed to be a problem. So it's just about understanding how each organization works and how different roles inside works. So that's also a question to you all, right? So if you could imagine yourself in your organization. So if we want to introduce, or if you already run chaos engineering experiments, so how does that work for you, right? So who is responsible for running experiments, for triggering, for planning, so if you and your team own one application or more than one, so, and if you find a problem after an experiment supposed to fix that. So we would have like a ticket base to put on the board of your team. So you're gonna plan that fix or not. You know, is it urgent or not? So that's something that we find. So, and these are like good challenges. So the people side is also very important flow of chaos engineering. So from planning, from understanding what's going on, and from like exploring and get the results and figure out what to do next. So the people is very involved. Yeah, next, Andreas. Cool. So this one is also something that we were discovering as we were investigating the tools and learning more, because at the end of the day, we have to explain to our colleagues, right? We have to explain to security engineers, to platform people that what we're gonna do exactly and what's gonna happen, right? It's not about only, oh, we're gonna crash things and see what's happening. So we need to understand, and we had to explore there to be more confident with the tools we were using and building together. And that's just to share with you. So how we see like chaos engineering tools these days, right? So usually there is like a chaos injector component thing, right? So for example, we're gonna demo like CPU and network chaos, right? So there is something that changed the behavior of CPU, right? So for example, for Linux machines, there is like a program, a command line that can like just right. And if you want to increase CPU, that's something like that will be used at the end, right? But since we have, let's say in our case, we have a Kubernetes cluster, and each node has like lots of applications containers running in different namespaces. So we need like a tool that will be able to select the correct pod or the correct container and limit that experiment to one or more namespaces. So these are features that we might be looking for when you're looking for tools. Additionally, so tools, they offer different features regarding the orchestration part. So some tools, they have like web app as dashboards. They handle like different users to trigger experiments from this web dashboard. So other tools, they have better experiment results and monitoring by itself. And sometimes we need that, sometimes we don't. But these are the aspects that we were learning that were important in a mature tool. And or if you want to glue together different tools, this setup and this set of features, so we would be confident running things in our environments. Cool. Okay, time for demos. Yeah, let's get our hands dirty. So yeah, you probably may have heard about the hipster shop, right? So on the right, top right here, the screenshot I'm gonna show you soon on my own browser. But this diagram is very nice. So it has this setup. So this hipster shop is basically like an e-commerce. So you go to the browser and you see like a website with some products there. But behind the scenes, we have all these components running, right? So I can see like here in the middle, the front end receiving ETP requests, but other several services behind the scenes, right? And it's still like this is open source. On GitHub, on like playgrounds, and it's very nice because it's kind of replicates like some real life scenarios that we have, where we have one application that depends on several other applications, and it's really nice as a playground for chaos engineering, because if we like change the behavior of one application, so we would like to figure out to see something changing for an application that depends on their one. So that diagram is just there to show you what we have behind. But yeah, let's see.
Okay, I think
let's try something and see how it works.
I'm going to stop sharing now, so you can share, Rafael, your environment.
Cool. So share my screen. Yeah, let me find my window. Andreas, can you see my screen?
We can see, yes, your screen. It's the background, right? I don't know if you're sharing anything.
Oh, really? No. So, okay. Let me try it again.
I can also hear an echo somewhere.
Too careless. Right, so what Rafael will show now is the CPU experiment. What we're going to do. Yeah, now we can see the presentation.
Okay, so that's what I'm gonna do. So I have like a simple Kubernetes cluster running on a machine, right? So I'm gonna try to explain what I'm doing, even if you're not familiar with Kubernetes. So we have the front end application, right? Itself on the browser, like sends request, and this front end like uses the next service, right? Like products service, right? So we're gonna apply some CPU like overhead to this dependency, to the product service, and see what happens as a user, or try to investigate what's going on, right? So can you also see when I change tabs here? So
yeah.
Okay, so yeah, just like to mention, so that's the microservice demo that we take a look later, right? And I have it running on my computer here. Let me refresh to see if it's all right. The famous hipster shop, it has some hipster things here to sell, right? So I can just browse the products and add things to my cart, right? And my cart now has 2 items, or I could come back to the main screen, and yeah, and you can see there are different services going on. So for example, there is like a recommendation service, another cart service where the cart is being handled and stored, that follows that main diagram that you will see. So behind the scenes here, I also have like Kibana collecting logs of all my applications. So it's a very simple setup. So you just see like the logs being accumulated here. So we're gonna come back to this soon to see if we can see anything different or not. But let me refresh here. Still refreshing, but yeah, supposedly I don't have any problem, right? So you probably have your logging system on your company. So yeah, so nothing is going on. That's probably the retention, so it's not too long, just for a few minutes. But all right, so let's go to the command line. Can you see my command line?
Nope. We can only see a window.
No, so I think I'm just sharing one screen. So while sharing, I can only see the option to share like one window, not my full screen. So we're gonna switch back and forth. Can you see my turn now?
Yep.
Cool. So I have a few pods running here, right? So with Kubernetes, so I'm just using this client, command line client, to talk to the cluster, and I have permissions to do that, right? So I can list everything that's running there as pods, right? So I have all those pods here running, so which compose the entire shop, right? And like supposedly that should like map what we have in a real scenario where we have multiple applications running together. Right? So I'd like to adding some chaotic behavior to this service, so I would see the front end how to response, right? So I have like a manifest here, so where I will apply to the cluster. So in this case, I'm using Chaos Mesh, which is an open source tool. Just very simple and straightforward to use. So I have it installed on my cluster already, right? And here you can see I'm selecting that application. using like a label selector, which is something that all pods may have. We may label the pods, so that's how we find them, right? And I'm applying a stressor, which I will keep running 2 workers with 100% CPU load on them and see what happens. Cool, so I'm just gonna apply that thing. So apply file stress, yeah. So yeah. So actually it works like applying this new CRD, if you're familiar with that, and then like the tool itself will figure out that I applied a new object to the cluster and will do what needs to do. So I'd like to come back to my screen. So I'm gonna share again my browser. Yeah, so I can see, so with 2 workers, I didn't see anything, right? So maybe it's a little bit slower. So at least here I can feel like it was not coming like immediately, right? So that's something that you're gonna figure out by yourself when you're adjusting the experiment. So maybe you're just going lightweight and it's not a huge impact, which is good, right? So here yet, just refreshing. Yeah, an update, so I don't have anything going wrong. So cool. So I also have like this dashboard, which is quite nice. So Chaos Mesh has a simple dashboard listing what experiments are running. So I can come here, overview. So these are the types of experiment that this tool has. So there is one experiment here, right? So yeah. So what you're gonna do? I'm gonna just this one and gonna run a more heavy experiment and see what happens. So
Rafael,
I just that's a nice feature from this tool.
Rafael, we have like 5 minutes, so it would be good if we can show the other demo too.
Say it again, Andreas, please.
So we have 5 minutes, so it would be good if we can show the other demo as well.
Okay, cool. Cool, no problem. So what I'm gonna do, just reshare my terminal here. So I'm gonna very quickly enable some memory happens. So let me apply this again. So I'll come back to my screen. Let me reload this. So I have a new experiment running, and yeah, coming back here, let's see what happens. So boom, so something happened, right? And so in this case, following the full cycle of steps that we have, so I found that if I run like an experiment with some level of impact, so the application is actually impact, right? So the next step would be to understand how exactly that impacts my system and figure out if I need to fix something, right? So in the case of an application that has like high CPU, possibly, maybe, definitely don't want to apply how to do with that. But in this case, so if my team was like an app, so I don't want to show this ugly stack trace here, right? So a possible fix here would be to maybe to just show like a nice message or maybe a static page, right? So that's something that would be a possible fix here. And in case my server is not a server that might be crashing, which is that's something that's happening here, right? So just to close this, so if I have a proper login, so I should be able to drill down what was going on. So that's something that we find. So I have the COD service. Let's explore the cloud, the logs for the COD service.
Let's move to the next experiment because we have a couple of minutes only.
So let me know if you have any questions, but that's the full cycle of the thing. So we were applying an experiment and trying to investigate where things were breaking and see what you can do to fix that.
All right, so the last couple of minutes, I'm going to do this quickly. So we're going to do the same setup, right? We still have the hipster shop. And we're going to create now network latency. What I'm going to do, I'm going to execute one of the two experiments just to show you quickly how it works. I'm going to create actually latency between the front end and the checkout service. The checkout service is if you go to the cart, right? You're buying something. I like to buy this. It gets added to the cart. As you can see, I have opened my network console as well, just to check the responses. About 100 milliseconds. It's slow, but not, not that slow. And when I place my order, then it goes to the checkout. Okay, so I'm going to create latency between the checkout and the front end. I'm going to do that. I'm not going to show you my terminal just to be quickly. Okay, I'm using a different tool. I'm using Litmus, which is a different chaos orchestration tool, right? And I'm creating this network latency. All right, so so far now the experiment is running. Okay, let's see what's happening. It will be running for 2 minutes, so we have some time. All right, I want to buy this. I still see the response okay. All right, so that's expected. I'm not creating latency to the cart. I'm adding to the cart. I'm still okay, a couple of milliseconds. Remember, I'm going to introduce 5 seconds latency. Now, if I place my order, it's waiting, 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 and finally after 6 seconds, so around the, so we have the additional latency of 5 seconds, this happened. Okay, this is expected, right? This is working as we wanted to do. We just want to see that everything else is fine, right? Going back to the main website, changing the currency, which is the currency service, seems to work quickly. Again, the card seems to work quickly. Up to the cart. If I place again the order, then at least 5 seconds, right? So my experiment is now underway. I have made a hypothesis that, okay, if I introduce this latency between these two applications, the rest will be fine, right? I will have latency. I may lose some orders. This is a dummy setup, so we don't have live traffic, of course, right? But if you had live traffic, you could make an assumption, I'm gonna lose this many requests or that many requests. And in my case, I had also a Grafana dashboard just to see the depth in the bandwidth. That's gonna be updated soon. But essentially, this experiment at the moment shows that it doesn't bring down the whole platform if we introduce latency only between specific two specific applications, which is good news for the hipster shop application. It's not built so coupled with the other microservices, right? I see we are 2 minutes over time, right? But the main gist that I wanted to get through to you guys through the network experiment is there are ways, there are tools that you can create as fine-grained this experiment as you would like, even to the point if you have a very complicated microservice setup to really restrict it to between two applications or even to all of them, right? And then see the whole system, how it will respond, or even kill the DNS and then see what actually will happen. In this case, our hipster shop was fine. I can see now that the experiment is completed. So if I try again, everything should be back to normal, and it is. So our application was resilient enough to recover after this disturbance, right? After this 5 seconds delay, it still after that, it still behaves as it used to before the experiment. So it can be considered that we didn't find any errors at the moment. if we had more time, I would have executed an experiment with a cart service, which is more critical one. And if I introduce latency to this one, then more applications go down, then it's more interesting. But given that we don't have time, maybe that's something we can share with you guys later, how we can do this. Some last works from...
Sorry to interrupt. There is a question in the chat from Supratik that is asking, which tool did you use to generate the network latency?
So the tool that I use is Litmus. Litmus is an open source chaos engineering framework. You can look it up. It's also the one recommended by CNCF as a quite promising chaos engineering tool. You can check it out. It has an operator that you can deploy in Kubernetes. It's only for Kubernetes workloads. It's not for VMs at the moment. So it's very Kubernetes native. And this is the tool that I used. And in the previous experiment, the CPU, we used the Chaos Mesh, another open source tool, similar to that, also with an operator. Bring more questions if you want. Just a few takeaways from our side, from our experience, and then we can finish. First one, always close the loop. By that we mean never just stop when experiment is finished. Always look what actually you found and what you need to fix and retest. This is very, very important because just executing an experiment without taking any action doesn't make any sense, right? They will not really improve anything. Choose your chaos tools according to your needs. From our engagement with the client, we looked at a lot of different tools. We found a lot of different capabilities in these tools, like Rafael mentioned, injectors or orchestrators, or complete platforms like Gremlin, for example. There's always going to be the tool that will fit your needs or your requirements. So take a proper look at what you want your chaos platform to do and choose the right tool for you. Tight control over the blast radius. We touched this a lot of times in the past hour. Start small, expand, but always keep a very good control over what you're affecting. This will help also with your organization to bring the confidence level of chaos engineering to the appropriate level so that people are not scared to use it or are not afraid that it will break production, right? You do that by slowly creating chaos in a controlled manner and letting people know or showing to them that this is a good practice and it's not going to affect the whole production, at any given moment. And finally, fourth, there's a chaos experiment helpful to you, meaning that if you're a developer or a tester or an SRE or a security engineer, you're always going to find a real life event that you can simulate with chaos engineering before it actually happens. And this is key. It's not only for developers, it's not a functional test, it's for everyone, but you really need to think and design your experiments according to your needs. So what's coming next also from our side, because we are going more into chaos engineering the last year and in general reliability. There is another webinar, 17th of September, so that next Thursday, 11 a.m. We have a guest, Instana, and our own Cameron Wood with Pablo Baron. I'm going to discuss about automating observability. This is very key, right? Especially if you're in an SRE team or a platform team or a sysadmin, you really understand how important is monitoring and logging and tracing and all of that, right? So how do you automate that? What are the best practices there? Very interesting webinar if your role or your interests are applicable here. And last but not least, 29th of October, our Software Circus comes back with another visual festival, Nightmares on Cloud Street. You realize that from the date that is very close to Halloween. So we aim to make the event very scary in a sense of horror stories in cloud native, in production, things that went wrong at the wrong time, chaos engineering, all of these relevant incidents or events that you have found in your experience, and this interesting to share with others. So if you're interested, you can register or you can submit a CFP as well. Submit your talk if you have interesting things to share. And we really hope to see you there. That's all from us. Well, a few minutes late, sorry for that, but I think it was good to show the demos. We could take questions if you guys have more. But yeah, thanks for listening. And I hope that from today, you're going to start practicing chaos in your own environments too. That's it.
Thank you so much, Andreas and Rafael. I'll give you the clap as well. People are thanking in the chat too. Thank you all for staying the extra time. I hope it was worth it. I also want to give a special thank to Gremlin, the team at Gremlin, especially Patrick for the great talk that he presented today. It was very nice to collaborate together with us, and I hope you will be back as well in the future. Cool. Patrick, you're mute, but I can see that you are nodding, so I hope it's a happy reaction.
I'm good.
Okay. Any last minute question we want to ask, or we're good? Thank you all, and again, thank you for coming, and I hope you're gonna have a nice rest of the day.
Thanks, everybody.
Thank you.
Have a nice day.
Thank you, everybody. Yeah.
Bye-bye.
Thank you.